Hello everyone, good morning. Welcome back to our channel Learn Tech with Kiran. Today we will discuss about NFA, which is Non-Deterministic Finite Automata. Okay, in NFA includes in syllabus just because of it helps you to understand non-determinism and build a strong foundation for compiler design and other advanced topics. Let's now look at the NFA or non-deterministic finite automata, which is another model of computation just like DFA. In previous video we will discuss about DFA, what is DFA, how DFA is designed and how we will use in our compiler design. Similarly, in today's video, we will understand the concept of non-deterministic finite automata, which is NFA. We will understand the concept of formal definition of NFA, understand its notation, and we understand how it works with example. Okay, and lastly, we discuss about its application where your NFA is used. Let's move forward one by one. Okay, an NFA or non-deterministic finite automata is a mathematical model used to recognize pattern and process string, especially in automata theory and formal language. Just like it consists of finite number of states, just like in DFA, and NFA is made up of a finite set of states which help us to track the automata progress as it reads the input string. Next, an NFA reads the input symbol one by one or one symbol at a time, moving from state to state depending on transition rules, exactly like in DFA. This aspect is used. In next point, your transition for non-deterministic is differ. In DFA, there is a single input symbol and single transition from one state to another state with each input symbol. But in NFA, for a single input symbol, the NFA can go to more than one next state or sometimes not at any other state. NFA also allowed us with epsilon transition, which is moves between states without consuming any other input or any other input symbol. These are special transition where the automata can change states without reading any input character. The NFA is said to accept a string if at least one possible path out of many leads to final accepting states. Even if other paths fail, just one success is enough. But in DFA, it is something different, right? So, as per backtracking, because of its non-deterministic nature, backtracking or parallel path processing may happen. The NFA might explore multiple computation paths simultaneously. Mathematically, we are speaking, every DFA is a type of NFA, but not all NFAs are DFA due to feature like multiple transition and epsilon moves. Next point, which is your NFA is more memory efficient, but they can also be harder to simulate or trace, especially in real world implementation. Next point, NFA are often easier to design for problems like regular expression, matching or pattern recognition. However, due to their parallelism and non-determinism, they are more complex to implement in actual software or implement it practically. Unlike NFA, it can be in multiple states simultaneously, which makes it more flexible. Even though it looks different, it accepts the same class or of a language as your DFA accept. DFA had a 5 tuples or 5 part of tuple, 5 tuples, right? So your NFA tuples are M is equals to Q, which is set of state, summation, which is input symbol, transition, which is transition function. Here you can move to multiple states, but in DFA you have to move only for one state. Transition function is what makes NFA special. It allows us to multiple transition for the same input or even no transition at all. Q determines initial state and F is determining your accepting state or a final state, similar as in your DFA. So let's discuss or understand NFA with one example. Your example is constructed an NFA that accept all string ending with A. Only those strings supposed to be accepted by your NFA which is ended by A over input A and B. Here your tuple is defined. So let's discuss forward. Here is your transition diagram for NFA. You can see over here for single input A there is a multiple transition, and from Q1 which is a final state there is no transition for any input symbol as we previously mentioned in your NFA description, right? So this NFA accept only those string which is ended by A and starting with any of a element or any of input symbol. From this transition diagram we define our tuple as a your states are Q0 and Q1. Input symbol is A and B as mentioned in your problem statement also. So transition is your table. We will describe this table or design this table from our transition diagram. Q0 is your final state of initial state and F denoted by final state. In our diagram Q1 is a final state. So we are design here we are writing over here F is equals to Q1 which explain your final state is Q1. So we can combinedly write this tuple as something like this. M is equals to Q0 and Q1 which is your Q, A and B which is your input symbol. Transition we will design as a table. Okay, Q0 is your initial state. Here we are mentioning Q1 because our NFA having Q1 is as a final state. So let's design table from this transition diagram. So you can see transition table we can design from our transition diagram, which is when you are on Q0 state with A input you can go to the next state which is Q0 or Q1. With B input symbol from Q0 state we reach to the Q0 state. Now our design or our diagram doesn't contain any transition for any input symbol from Q1 state which is final state. So we can mention similar in our table from Q1 with A we not move forward with any other state, or with Q1 with B input symbol you are not moving to the any other state. There is no transition for A and B, but if you see in our previous DFA problem in previous video there is a unique and single transition for each and every input symbol from one single state in DFA, but as we are describing or we are explaining the NFA concept there is not necessary for input symbol transition from single state for each input symbol. You can see these are the some of application of your NFA. If you are going through previous video which is DFA, you can see this same application used in your DFA also. So your NFA also helps in lexical analysis in your compiler, as your DFA and NFA is the most important part of your phase 1 of your compiler, okay, which is syntax analyzer. Then for regular expression matching or pattern matching or pattern recognition, your NFA is also helpful, as well as in network protocol validation as DFA helpful or DFA is used. Similarly, your NFA is used in network protocol validations. Then natural language processing and digital circuit design is also using your NFA. Today's video we going to know or we know about NFA, which is your NFA is a flexible way or it allow us to multiple transition for the same input to making a design simpler, as well as your NFA is able to or use for language recognition power as similar as your DFA having, right? Your NFA are fundamental in building regular expression, compiler design and natural language processing like DFA, as well as we focused on its application, how you represent your NFA with how you represent your NFA with a table, as well as one example we elaborate in today's video. That's it for today's video. Next video, we will continue exploring more important topics from theory of computation. Don't forget to like, share and subscribe to support the channel and stay updated. Thanks for watching. See you in the next one.